algebraic fractions. The ability to manipulate algebraic fractions in this course is crucial, absolutely crucial, because we would just deal with it in so many different ways, in polynomials, in calculus, and so on. We just need to be able to manipulate the algebra. Always factorise first. Before you do anything with algebraic fractions, first thing you do is factorise. Before anything else, factorise. First thing you do is factorise. What's the first thing you do? Very good. Factorise. Okay. Now, how to put this in words is a bit, So then only cancel, not bits of them. So you can only cancel a complete parenthesis with a complete parentheses. Some people just love going crazy. Oh, look, there's an X. Cross them all out. It doesn't work. Got to be complete. So let's have a look. Now this one, of course, can't be factorised. It's just a single term on a single term. But we can have fun cancelling. This particular fraction you're going to see a lot in one of our topics later on called parametrics. It's a very common little fraction that appears. And so we would like to cancel it and make it easier. So always factorise first. In fact, I can factorise further than I've done because p squared minus q squared is, of course, difference of two squares. Now, and this is what I mean by only cancel complete. P minus q matches with the p minus q. That will cancel. A will cancel with the A. Leaves me with just simply p plus q on 2. Multiplication. Algebraic fractions, but we're multiplying. Well, we know when we got fractions and multiplying, what's the first thing we do? Factorise. Very good. Hasn't changed. Rule has not changed. Some things don't need to be factorised. I like to put parentheses around it so I know that's a whole thing that I've got to cancel. So, all right, they're the easy ones. X plus 1, 3x plus 1. Which one do you reckon I factorise next? Like if it's you, which one would you go for? Yeah, the difference of two squares is going to be the easier one. So, all right, let's do that. Now, I've got to factorise 3x squared plus 2x plus 1. Minus 1. And of course, it's very easy to cheat at this point. Because you know that they're going to be things that cancel. So if I had to gamble right now, I'd say 3x minus 1 times x plus 1. It's the only thing that hasn't got a matching partner with it. I could be wrong. It's probably not worth. It's probably a good idea to check and make sure. But, use those sort of patterns to your advantage. If you see it there and you think, oh, well, this might give me a bit of a hint how to factorise this rather than spending a lot of time doing it. As it turns out, that is indeed the factorisation. Be careful, that won't work all the time. Make sure you check. But it can give you a hint by, I've already seen these factors. There's a good chance something else is going to factor because otherwise, why did they ask me this question? They want to see if I know how to cancel and things like that. So, all right. 1. Oh, all that work for just 1. There you go. Division. Well, that's a little bit different now. What's the first thing we do when we want to divide? It's still factorised. That hasn't changed. But I'm also going to turn the second one upside down and turn it into a multiplication. So, 3a, 6a squared b. Which one's going to be easier? Probably this ab minus 2b squared, isn't it? It's just got a common factor of b. Then, this one's not as easy as just guessing this time. Pretty safe bet a minus 2b is probably going to be one. But if we look at this, actually it's a perfect square. So it's a minus 2b all squared. Okay, so we got the 3 will cancel with the 6, and a with the a squared, a b with a b, the a minus 2b with one of the a minus 2b's. And there we go, 1 over 2a, a minus 2b. Subtraction. You can't just add and subtract fractions, because before you can add and subtract fractions, what have you got to do? Oh, who said common denominator? Oh, yes, I knew it'd catch someone sooner or later. No, first thing you do is factorise. Always factorise first, because you can't work out your common denominator until you factorise. So, there we go. Now, I don't know how you work out your common denominator. I work it out by simply saying, if it's not there, put it down. Okay? If it's not there, put it down. What do I mean? I start moving along. A, oh, it's not there, put it down. A minus 1, oh, it's not there, put it down. A, oh, it's already there, don't have to worry about it. A plus 1, oh, it's not there, put it down. There's my common denominator. A lot of people will make a common denominator there of a squared, a minus 1, a plus 1, because they just multiply the two together. That'll still work, but it just means there'll be some more simplifying that'll happen later on down the track. Okay? So, not there, put it down. And if you're dealing with different powers, then the highest power is what has to be there. Okay? So, if in one of them I had a squared and the other one I had a, well then the a squared had to be in the bottom. Now I've got to work out the top. So once I've gone, if it's not there, put it down, I then say, what's different? Okay? So, not there, put it down. Now we're going to compare and say, what's different? Hey, the denominator was, in this first fraction, a minus 1. It's now a minus 1, a plus 1. What's different? So that's what I multiply the top by. So it becomes a plus 1 squared. Minus, now let's have a look. In the second one, the denominator was a plus 1. What's different? A minus 1. So that's what I multiply the top by. Now, we can't do any cancelling yet because the top is not factorised. 2 ways, 3 ways actually, I can think of doing this. I could expand the whole thing out, see what happens. That would certainly work. Difference of 2 squares, you'll notice. That would work. Or I could use another idea that simply says, hang on, if I've got a perfect square minus a perfect square, I'm going to be left with 4ab. Right? Because the a squares will subtract the b squares. Will go. So that twice ab will be in both, but one will be a plus and one will be a minus. We've just got to make sure we get the sign right. In this case, it'll be a plus. So I know the top of this is going to be 4a. Okay? And again, that's using patterns to save yourself some time. Now, probably for the sake of this example, if I know myself, I've actually expanded the whole thing out. So, okay, you expand the whole thing out and you collect like terms, but sure enough, we end up with 4a. Okay? So let the pattern of the maths help you. Oh, hang on, a will cancel with the a now. Now that everything's factorised. So there we go, 4 and a minus 1, a plus 1. Ooh, 3, woohoo. Now it's getting tricky. Oh, no, what's the first thing I should do here? Okay, I'll factorise. The first one's done for me, second one's done for me. The third one is the difference of 2 squares. If it's not there, put it down. X plus y squared, put it down. X minus y squared, put it down. X plus y, it's there. The higher power is the one I want, so squared, good. X minus y, it's there. There's my common denominator. What's different? In the first one, okay, I've got to multiply that by x minus y squared. That's what was different. Plus x plus y squared. Minus 2 lots of x plus y, x minus y. So again, I could expand the whole thing out. But let's have a look at what we got. X minus y squared plus x plus y squared. So this time it's the middle terms that will cancel out. So I'll be left with 2x squared plus 2y squared. Now, the last one is the difference of 2 squares. And I'm saying minus 2 lots of that. Depends how much your head can cope holding on to this. But we've got 2x squared plus 2y squared minus 2x squared minus 2y squared. I think I have ended up with 4y squared in the end of all that. But if ever you're in doubt, and you find yourself making mistakes, write more lines down. Don't try and do too much in your head if you're making mistakes. If we did expand the whole thing out, sure enough, there it is, 4y squared. All right, 1D. That would be a point.